Welcome to Kitchen Chemistry. Today we'll be doing 3 science projects using items you may already have at home. Our first project is invisible ink. You will need some basic supplies. First, you'll need paper. Printer paper or notebook paper will work. Then, you will need lime, lemon, or another citrus juice, or you can use vinegar instead. You will need a paintbrush, or if you don't have one, a cotton swab will work. And finally, for the grown-ups, we will need a heat source.
Hi everybody, welcome to Kitchen Chemistry, our Friday STEM program from PGCMLS. Today we are going to be doing lunchtime STEM, and we are using some of the items that you may have in your kitchen to do some experiments and also some fun activities. So today my daughter Daphne is going to be helping me and my son Ronan, and we're going to start off by making some invisible ink. And then after that, we're going to talk a little bit about acids and bases and the pH of those. We're going to start with invisible ink, and to do this, you're going to need some ink. And for ink, we're going to be using some lime juice for Daphne and some vinegar for Ronan, and that's just basic household white vinegar. You don't need a whole lot of it. They're going to be using paint brushes to draw with on regular paper. You can also use cotton swabs as your paint brushes. If you don't have any paint brushes lying around, you could use a toothpick. You could even use the edge of a fork to draw with. Just something to put your invisible ink onto your paper. So guys, why do you think someone might want to have some invisible ink?
To communicate secretly.
Sure. And why would you want to communicate secretly? What kind of person might want to send a secret message?
Like a bad person. So like if there's anybody trying to find clues, they can't.
Oh, like about their secret hideout or something?
Yeah. They're telling some other bad person.
Yeah. Who else might want to use?
A spy?
Oh, a spy. Yeah, definitely, because they wouldn't want someone to intercept it and know what they were saying. But you might want to use invisible ink in your house too. You might want to send a secret message to a grown-up living in your house or a brother or sister. All right, so to start, we're just going to take our paper and you guys can write out a secret message. Okay, go ahead. And while they're writing out their secret messages, I'm going to talk to the grown-ups about some of the materials we will use for this experiment and then for our later experiments. So you're going to need a heat source to develop these secret messages. That could be anything from an incandescent light bulb to a lighter that you would use for a grill, to a kitchen burner, or even the oven. It's really important that grown-ups are helping with the developing of the messages, just so that we don't have any injuries. We also are going to be doing an experiment later using red cabbage. So we'll need half of a red cabbage. We'll also need boiling water, containers to hold these in, and then we're going to need a whole array of different household products to test. We will be using baking soda, vinegar, seltzer water, cream of tartar, and lime juice. Okay, so I think Ronan is almost done with his. And I think Daphne's about done with hers. And we're going to just let these dry, and then we'll try to develop them. Okay, so we gave our messages some time to dry. Ronan's is still drying, so when you're doing your message, you want to not saturate the paper too much. So we're going to develop Daphne's message right now. As you can see, we've still got our white paper with our invisible message. We are going to need a heat source for this, so time for the grown-ups to do the work here. I'm going to be using a lighter just so that we can show it on camera, but my preference is actually to do it in the kitchen using the stove and just holding it over the burner at a distance. That develops it pretty evenly and quickly, but grown-ups make the determination about what works best in your house. Okay, can you guys scoot over since I'm going to be using a flame here? So we're going to get our lighter lit up, and I'm going to try to do this without scorching the paper badly. It is going to need to sort of color it a bit to develop the ink, but we don't want to light the paper on fire. So parents, if you're using a lighter, I like to just kind of keep the flame moving a bit so that it doesn't concentrate in one area for too long and create really heavy scorching or light the paper up. I think we've about got our message developed here. So you can probably see Daphne drew a butterfly and wrote beans, which clearly the secret message was not to me, unless that's what she wanted for dinner. But you can see that our invisible ink did develop, and we can read our message now after we used our heat source.
Our second project is about acids and bases. We will be making a cabbage juice indicator solution and testing substances in our houses. You will need half of a red cabbage, about a liter of boiling water, lime, lemon, or another type of citrus juice, vinegar, cream of tartar, seltzer, and baking soda. As long as you have the red cabbage indicator, you can test almost any substance in your home.
Okay, so now we're going to make an indicator, and that's going to tell us whether the solutions that we have are basic or acidic. And we're going to make our indicator with something that some of you may have at home, and that's red cabbage. So I have half of a red cabbage here. Looks kind of cool inside. You said it looked like a brain.
Yeah.
It does sort of. We're going to chop it up. So again, with a knife, make sure that you have a grown-up doing this step for you or supervising you if you're allowed to use a knife at home. We're going to chop up the red cabbage, and then we're going to get about 2 cups of it. So Ronan, can you put some of that into the dish for me? And kind of break it up so that it's not all put together like that. Yeah. And we're just going to kind of keep chopping and adding to our measuring cup until we have a good amount, but about half a red cabbage should be right. The red cabbage is flying. Let's move some of this in there too. So Ronan's going to keep working on breaking up the cabbage. And that looks pretty good. We've got, okay, I think that's good. So we've got about 2 cups here, you can see on our measuring cup. And the next step of this is going to be to add some boiling water to it. So we're going to go ahead and boil the water in the electric kettle right now. You might want to use water from a different source, maybe a pot on the stove. Again, just have a grown-up help you with that. But I'm going to go and get the electric kettle with the boiling water, and then we're going to make our solution. were waiting, we boiled some water. I put it in my electric kettle. You could do this in a tea kettle or a pot on the stove. Again, when you're working with boiling liquids, you want to make sure that a grown-up is helping you with this because you don't want to burn yourself, and you also want to make sure that a grown-up knows what kind of experiments you're doing with the things in your kitchen. You'll notice that Ronan and Daphne and I are all wearing dark colored t-shirts. We're doing that because once we add the water to the red cabbage, it can stain. So you want to make sure you're wearing something that's not a white shirt or nice clothes, just in case you splash a little bit when we're transferring liquids later. We've boiled about 1 liter of water, and we're going to just go ahead and add that to our cabbage in this large pyrex container. And then we're going to let that steep for a little while, just like we would a tea bag. And the color's going to get darker. You can see right now it's a very pale blue, but we're going to let it develop for a few minutes, and it's going to get some of the chemicals out of the red cabbage and create a darker colored liquid. And our liquid is going to be our indicator to test out different household items and products to see whether they're acids or whether they're bases. Okay, so we have a lime and we have a knife, and only a grown-up should use a knife, so you want to make sure that you talk to your grown-up and have them help you with this experiment. We're going to cut the lime in half, and then I'm going to have Daphne and Ronan help me squeeze the juice out of it. So now we have 2 halves of the lime, and we're going to squeeze the juice out of both halves. And I have a funny juicer. It's very old, but it works really well. So we're going to put the lime in, and Daphne's going to go ahead and squeeze it. Just going to squeeze it really hard. Good job. Okay, we have a squished lime. I'm going to squeeze it one more time to get the juice out that side. Great job. I'm going to take it out, and now we're going to let Ronan do his, and then I'll pass it to you. Okay, go for it. Push it hard. Okay, do it the other way too. Get all the juice out of it so that we have enough for our experiment. Good job. All right, now we're gonna pour the juice into a container, and then we're gonna set it aside for the next part of the experiment. Okay, so we let our red cabbage solution steep for about 2 or 3 minutes, and you can see it's a nice purple violet color instead of that light blue that it started as. And Ronan, if you could get the pH chart for us. So we're going for a violet color with our cabbage water solution. That means that we're in the right range for pH. We're trying to get a nice neutral pH of about 7, and we're somewhere in that range right now, I think. So it looks pretty good. Now we're going to transfer the liquid into a different container. Daphne's going to help me by holding a sieve so that we can get the pieces of the cabbage out of the water. We don't want those big chunks in there when we're trying to do our experiment. All we want from this is for the anthocyanin from the cabbage to get into the water so that our liquid can serve as an indicator for us. We don't really care about the cabbage anymore. So I'm going to pour this in. Again, get a grown-up to help you with this because the water is very hot. So we're just gonna pour it through, and the sieve should catch all of the cabbage and keep it from getting into our indicator liquid. That looks pretty good. Okay, put that back in here. You can just put the sieve in there too. Great. Okay, so we've got a nice big container of our red cabbage indicator fluid, and we are going to transfer that into some smaller containers. Daphne, can you pass me the small containers? Yep, can you just get a whole bunch of them? So we're using little ramekins here. These are just pyrex glass containers. Clear is good because it'll let you see color changes, which is going to be really important when we're trying to determine our acids and bases. If you wait for the water to cool, though, you should be able to use clear glassware or even a plastic cup, but do let your indicator cool first so it doesn't harm your drinking cups or your plastic cups. Could you also pass the big beaker and that container? Great. Okay, so we're just going to transfer some of this indicator fluid into each of these. Somewhere between 50 and 100 milliliters is plenty. You can just kind of eyeball it. You're just going to divide it up among your containers, leaving enough room to add some of the products that we're testing. And cabbage water does smell a little bit funny. You guys probably can smell it. What does it smell like to you?
Feet.
Yeah, it does kind of smell like feet or dirty socks. It's not very neat with that one. Okay, so we've got all of our containers filled, so we can start testing some of our products that we got out, and we will get those ready to go and try them out one at a time, and then use our chart for reference to determine if they're acids or bases. All right, Daphne, can you pass over the baking soda? So our first product that we're going to test is baking soda. And I'm going to hand that over to Ronan. Let me get some things out of the way. So Ronan is going to add some of the baking soda into one of the ramekins. And we already have a color change. So what happened to this one when you added the baking soda?
It turned light blue.
Okay, do you want to try to add one more spoonful in there? And it's kind of fizzing, so baking soda is something that most people have in their house. You use it for cooking. Some people put a container of it in their freezer or refrigerator to make it smell good. You can use it with your laundry. And we're going to use our chart again. Ronan, can you get the chart? And we're going to compare it, and it's sort of a bluish green color, right? And that gives it a pH of about 10 is what we're going to estimate, which means that it's pretty basic. So we're looking at acids on this end, bases over here, so it's very alkaline or a base. And that was our baking soda. So we tested that one. We're gonna put that aside, and we'll try out something else. All right, our next one is cream of tartar. And this is something that might be in your kitchen. It's used for cooking. You can use it for making meringues for pies is something that you commonly use it for. And we're going to test this one out as well. Let's get a clean spoon. We want to make sure to use a different spoon each time we test something different so that we aren't messing up our results by having some leftover of the last item that we tested still in it. We want pure results when we're testing things out. All right, so Ronan's gonna add some cream of tartar to our cabbage water here, and we're gonna see what happens. And that's fizzing a little bit. We have a slight color change there. So let's compare. So what happened to the color this time?
It turned lighter, like pinkish.
Okay, let's add a little bit more cream of tartar and see what happens. Do you want to stir it up a bit? Okay, and let's let it settle. And do you want to grab the chart? Let's take a look here. So we're going to compare it to our control, which was pH of about 7. That's our cabbage water. And our liquid now is a lot more pink.
3.
Right, so you think it's about at a 3, so somewhere between that red and purple, kind of a pinkish color, which means it's an acid. So our cream of tartar, we think is an acid. All right, let's test something else out. Daphne, do you want to get, how about the lime juice? Right there. So you'll remember we cut up some lime earlier. And what does a lime taste like?
It's sour.
So do we have a
It's pretty
prediction as to whether this would be an acid or a base?
An acid.
Okay.
Yeah.
Sour things are often acidic, so we're gonna see if that turns out to be the case. You wanna scoop some in there? And we had a very fast change to a pink color. Let's add a little more and see what happens. Let's keep going. Perfect. Okay, so we can compare it to our purple cabbage water here. So we know it's more acidic. And then would we say?
It's about like 2.5. That's what I think. Because if it's 3, it's not the same as that pink.
Yeah, the cream of tartar was very pink and this is a little bit more red.
So like 2.25.
So like maybe 2.5 for the pH. So it's more acidic, we think, than the cream of tartar, right?
And it's more red
Mm-hmm.
than blue.
All right, let's try some vinegar. Okay, so we're gonna just try pouring some vinegar straight into the solution. And vinegar is another thing that you have in your house most likely. And some of you may have combined vinegar and baking soda before to make it fizzy, to make a bottle volcano. That can be kind of fun too. We're gonna see what happens when we add it to our indicator. And let's.
Very fast change.
It did change it very fast. It's definitely acidic, right? It got a lot more red than purple. Let's compare it to our other acids though.
Yeah, I think it's.
So do you think it's more or less acidic than?
More. I think it would be a
You think
1.
this is redder than this?
Yeah, I think it would be a 1 or a 1.5. I think they're about the same.
I think they're about the same too. If anything, I think maybe it's a little bit pinker,
Yeah.
kind of in between those. It's got a little bit more purple yet to it than this one.
Like
So I think the vinegar is
3 and
probably between
quarter.
the cream of tartar and the lime juice in terms of acidity.
Yeah, I think so.
Okay,
Like a 3.5 or something.
so we're gonna try one more item. Can you pass the seltzer? So we just have some plain seltzer water here. And we're gonna pour it into a bowl. Can you hold the bowl for me? Can you hold it up a little bit? Great.
It didn't change much.
Not too much.
It only light. up the color and then it darkened a bit.
Yeah, so
I'd say
it lightened it a bit, but it's definitely
like a 5.5.
Yeah, it's definitely closer to neutral than anything else we tested, right?
Yes, it's less,
So,
but it's less than 6, definitely.
if we sort of organize
It's not the same.
Is that kind of the order we
Yeah.
think they ended up in?
Yeah, this would be like a 5.
So the most basic was our baking soda, and then our neutral, which is about at a 7 pH, was our indicator fluid, then our seltzer, then our cream of tartar getting more acidic, our vinegar even more acidic, and our lime juice the most acidic of all. Okay, so we also wanted to see what would happen if we combine some of the things that we tested just a minute ago. So we've got a nice big beaker of our purple indicator liquid that we made from the red cabbage. Daphne's got some of the lime juice over here, and then Ronan has some of the baking soda. So we took the most acidic thing that we tested, and then we took the most alkaline thing that we tested, or basic thing that we tested with the baking soda. So I'm gonna have Daphne add some lime juice to our beaker. And you can see what happens. I'm getting a really nice color change already to a kind of fuchsia color. And she's gonna put a little bit more in there. And so we've got a nice bright pink, almost red color because of the acid in that. So, hold on. So now we're gonna see what happens if we take the pH, which is somewhere close to a 2 now, and we add something that's on the opposite side of our chart that's very alkaline or basic. All right, Ronan, you can add some of that baking soda in. And it's fizzing up really well, and let's see what happens to the color before you add any more. It got it back to sort of a purple color, right? It's a little bit blue, but it definitely got it closer to neutral. So you can add a little bit more. Go ahead. You can put the whole thing in. I'm gonna give it a swirl in there. And we are back to a pretty basic solution here. It's a nice blue color. And so we saw that with our indicator fluid, we had something that took it to an acidic pH. We were able to neutralize it by adding a base to it, and then when we added more base to it, it took it to a basic solution. And that is very similar to how certain medications work when you have an upset stomach or heartburn. It tries to neutralize the stomach acid. So if your stomach is too acidic, you take a medicine that's basic or alkaline, and it pulls it back that direction to bring it back towards neutral so your stomach doesn't hurt anymore. We did something similar here in this beaker.
If you enjoy the science projects we did today, you can find some similar projects and ideas in some of the books on Overdrive, like Why? Answers to Everyday Scientific Questions by Joel Levy, which is full of interesting scientific facts. Or Chemistry Science Fair Projects by Robert and Barbara Conklin, with tons of experiments using food and kitchen items. Or Amazing Kitchen Chemistry by Cynthia Light Brown, with great ideas for fun kitchen experiments for kids, some of which you can eat. Thanks so much, everybody. Have a great day.